Hello, and welcome to Fast Forward. Now today we're gonna discuss a topic that is really pivotal to universal storage, and I've got somebody with us who has been with Vast Data since the very beginning, one of the co-founders, the chief marketing officer, and absolutely the chief evangelist of Vast Data, Mr. Jeff Denworth. Jeff, welcome.
Thank you for having me, Daniel.
You bet. So Jeff, let's start kind of from the very beginning. Why do we have tiers in data centers today when it comes to data storage?
Well, it turns out the concept of tiering goes back as much as 40 years ago. Organizations were trying to figure out how to save money by balancing capacity versus their performance requirements and buying as high performance infrastructure as they could get their hands on, while at the same time moving their older data off to lower capacity infrastructure.
So all right, we started off going back 40 years. And obviously a lot's happened in the last 40 years, especially when it comes to technology. As we sort of prefetch and we see that come of age, wasn't the answer supposed to be flash? Wasn't flash the one tier to rule them all? You know, super performant, super scalable, and cost effective. Why didn't we get to that point? How are we in 2021 and we're still tiering?
Cost is still the overarching argument for why the data center hasn't gone today to be all flash. And what we find is that there's still more than a 10x premium in the cost of legacy enterprise flash systems versus what you can buy from a hard drive based approach. And so long as the industry embraces this idea that you can't have both performance and capacity, legacy architectures will always be comfortable with this idea that you don't have to solve both problems at the same time. That's the trade-off that Vast Data sought to break when we started the company more than 5 years ago.
So I think that there's this overarching concept of cost that you mentioned, and I definitely want to come back to that because obviously we wouldn't be here if we hadn't solved for that. But I also want to double click on this idea that you have to start making decisions about where your data resides.
Sure. So, from the perspective of where is my data? I think when an enterprise organization goes and offers different storage classes out to their user community, essentially that's an admission of the fact that they can't solve the problem of supporting both high performance and high capacity. So as opposed to trying to solve it, essentially they say, you as a user organization, please go reconcile to these different storage classes. And here, what we found is that in any public cloud service, what you find is that same wide selection of storage offerings being expressed as services that get sold back to either users or to administrators is still different classes of storage. And so the problem definitely hasn't been solved. And we see some just crazy pathologies in our customer environments as they work to resolve this imbalance between performance and capacity. The interesting thing is if you think about that cluster that was built 20 years ago that started it all, and you looked at that same infrastructure today, if you bought it with modern hard drives that have much greater capacity, you'll find that the average performance per bit that customers are deploying today on hard drive based infrastructure has gotten dramatically worse. And the conversation around storage tiering only becomes more acute. And nobody looks at the problem from just the fundamental level and solving it all together.
To turn the contrast up a little bit more, as you think about, take AI. Talk about what tiering does to inhibit the growth and the success of those projects.
If you're going to build the most accurate model, well, then you need to expose it to the most representative data set. And if you want something that can handle any condition, let's take, for example, a self-driving car, you should show it all the possible scenarios that it will encounter throughout driving down the road. And so play that forward to storage, and you think, okay, well, in order to go and train and build models on top of these large reserves of data, modern processors need to chew through this infrastructure repeatedly as codes get refactored and rethought. And so this space is moving so incredibly quickly. But the one thing that this space doesn't have tolerance for is the latency of a mechanical hard drive. And so what we're finding is that customers are not only rejecting hard drives as the basis for which they implement their training agendas, but they're also refining the definition of what you could think of as an archive.
So I want to come back to cost because I think that folks who would be watching this video or who've been exposed to VAST, I would imagine there's a little bit of skepticism around, have you guys actually cracked the code for the all-flash data center?
Sure. So Renan talked a lot about this disaggregated and shared everything architecture that can be built using modern technologies. And so what we've done is we've pioneered a number of new algorithms on top of this new type of cluster architecture that essentially allow us to build a series of compounding factors that ultimately all multiply against each other to deliver an unprecedented level of storage savings. And so it starts with our adoption of hyperscale flash. And as time goes on, we'll adopt future generations of flash, but it starts by having our own distributed data placement engine that sits on top of these devices. And this next generation flash model ultimately allows us to shape writes as they go into low-cost QLC drives. And what we've achieved from that is 20 times the longevity than what the drive manufacturers originally expected from these devices. And so the first thing that we've done is we've basically started from the basis of a very low cost of goods. QLC flash is hyperscale grade flash. The second thing that we've done is we've gotten 10 years of longevity out of these devices, which, if you think about it, it avoids at least one refresh cycle that customers would have to make with other either hard drive or even flash-based technologies. The third thing that we've done is we've pioneered a new erasure code. A new erasure code that's global in nature. We write across all the devices within a cluster. We can do that because of disaggregated and shared everything principles. And what we've solved for essentially is the problem of long rebuilds that happen as you build wide write stripes. And what we've done is we've dramatically shrunk the time to rebuild a lost block or a lost drive. And we've also increased the number of redundancies that you have in a RAID stripe as compared to conventional error correction algorithms. The final thing that we did is implemented a new global data reduction algorithm. We call this similarity-based data reduction. And this new similarity reduction allows us to look across all the blocks within a distributed storage system and find patterns within just as little as 2 bytes. So it combines the best of both deduplication and compression. It avoids the worst of both of those approaches. And what we're finding is that even as people store compressed or even encrypted data into our system, we're finding opportunities to further reduce data down. And so when you combine that data reduction on top of low overhead QLC flash, what you get is something that you can keep on the floor for 10 years at roughly the cost of a hybrid or hard drive based storage system.
Awesome. Well, Jeff, we're going to leave it there. Thank you for joining in this video series. Super illuminating. For anybody who's watching this, if you want to continue the conversation, please click contact us. We'll reach out and we'll continue this conversation with you. We're going to be coming at you with a number of other videos dealing with other topics relating to modern data storage. So please follow us, continue to tune in, and take care. We hope to see you soon.